Hi, welcome back to Mr. LaFleur's weekly vlog, where we cover interesting math topics in bite-sized videos. This week we'll be talking about the beautiful and intricate world of fractals. A fractal is a geometric figure that either has the quality of self-similarity or chaotic roughness as you zoom in on the shape. We'll talk about both cases and why they're unique and mind-boggling. First off are the self-similar fractals. By self-similarity, I mean that the entire image is contained within itself somewhere. Take the Sierpinski triangle as an example, which is constructed by removing small triangles from a larger triangle. We can see that the entire image is contained within itself 3 times, thus giving it this self-similarity property. There are tons of fractals with this property, including the Koch snowflake, the Menger sponge, and the famous Mandelbrot set. These figures show up in surprisingly a lot of places outside of geometry, including group theory and computer science. Often these strange shapes give us a geometric interpretation of the idea of recursion, an extremely important concept in computing. The other common interpretation of fractals has to do with the idea of chaotic roughness, meaning no matter how far I zoom in on a fractal, its edges always have this jagged, unpredictable nature. A commonly known representation of this was when mathematicians were tasked with measuring the coastline of Britain. We can see as we use smaller and smaller lengths that close in around the true edge of the island, the line gets more and more jagged and more chaotic. And in fact, no matter how far I zoom in on this line, it'll never smooth out. Another unintuitive result of this is that the length of this fractal curve tends to infinity, an idea first posited by Benoit Mandelbrot, the namesake of the fractal that we saw earlier. So, these fractal shapes not only show us the insanity of infinite curves, but how this infinity can be roped in and used in other fields. That wraps up this week's extra math content. I hope you enjoyed it. I'll see you next week.